Flood Coordination Study Activities 2020 to 2021 activity webinar. This is sponsored by the Center for Port Management Annual Workshop Series, and I want to thank Eric and the Center for hosting us for this. That center hosts webinars every few months which address regional and industry issues, and this is the kickoff webinar for 2021. I would also like to thank our sponsors, Lamar University, University of Texas, Sabine River Authority of Texas, Lower Neches Valley Authority, the Center, and soon the Texas General Land Office. And with that, I would like to introduce the president of Lamar University, Dr. Kenneth Evans, for some opening remarks. Dr. Evans?
Thank you, Liv. It's my pleasure to open the Center's first 2021 seminar. Center for Port Management annually sponsors webinars in conjunction with the Southeast Texas Waterways Advisory Council, SETwac. Stromberg chairs the Council's Education, Research, and Workforce Development Committee, working with the Council and industry partners as well as Lamar University faculty to identify, plan, conduct the Center's continuing education program. It's particularly appropriate that our leadoff seminar address such a clear and present opportunity to enhance the resiliency of the nationally important assets here in Southeast Texas through highly effective collaboration among Texas universities, industry, state, and local governments. The Southeast Texas Flood Coordination Study is developing databases from throughout the Sabine Neches River Basin, utilizing new technology, facilitating more effective lines of communication to assist decision makers responding to flood events, and in the long run enhance the resiliency of our nine-county region. I'm proud to have Lamar leading this initiative through the efforts of Dr. Liv Hasselback, who you just heard from. The Southeast Texas Flood Coordination Study is an excellent example of the role the university can and should play in improving the quality of life in the communities outside of the campus. I'm looking forward to this morning's update and beyond to the benefits this study will convey to our citizens and our economy. I'll turn it back to you, Liv.
Well, thank you very much, Dr. Evans. As you can see on the screen here, our agenda today is, I'll just do a brief introduction. Unfortunately, Steve Moon from Motiva has been called away to a meeting. When you're part of a resiliency group, people get called away a lot. Then we'll have a presentation by Dr. Chin Chian on dredge material research in the Port of Port Arthur, and Dr. Fuller on an up-and-coming high-frequency radar project for Sabine Lake. I will be going over a very special potential low-cost sensor project that we're working on. And again, Carmen Apple just emailed me this morning. She's been pulled away to address some of the new vaccination hubs in the state. So she just asked me to make a few comments on her behalf. And then we will end with Christine Tice of University of Texas on some Homeland Security exercise evaluation program exercises that were done on some regional flood needs and on our river gauge network here in Southeast Texas. So with that, I will go over the study a bit. So we started in the fall of 2019 after Imelda, when it was obvious that Southeast Texas had some of the most severe flooding in the country, and we're probably apt to do it, and trying to bring together the many agencies and other people affected by or who could impact or work with flooding issues. And you can see by this wagon wheel here that the participants in this flood coordination study, and it's all ad hoc, it's all volunteer at this point, are many and varied. And since we started, other groups have joined, like industry members, Department of Homeland Security, and there's somebody typing, if you could mute, thank you. Some non-government organizations, etc. So some of the things we work with is communication, how to help people make decisions for mitigation, and how to support the data and needs for mapping and modeling for flooding here in the state of Texas. And so with that, I am going to stop sharing, and I am going to ask Dr. Chian to please share her screen and start her presentation. Dr. Chian?
Thank you, Liv. I'm sharing here. Let me know if okay. Hmm?
Yes, we can see your screen now, Dr. Chian. Go ahead and start.
Okay, let me go back to the front. Good morning, everyone. Thank you for these opportunities to present our research on study on the causes of portal ulcer dredging. This study was mainly done by my graduate student Jennifer Gulindos, was my advisor. So Port of Port Arthur is a critical transfer facility in Southeast Texas. It's located in the 90 miles inland from the Gulf of Mexico. These are the pictures we took when we had a field trip. And aside, you can see how busy this port is. Then along the east side of the waterway, there are some bushes covered on this bank, and on this side as their main facility, there's a concrete docks here. So we analysis our possible sediment load that possibly from the bank erosion due to wake wash on the east side, or based on a possible deposition in the channel due to flood condition. So that's caused their almost every 6 months dredging activities. The objective of this study is try to investigate the causes of sediment loads and to better understand the sediment transport mechanics. So we try to calculate flow area reduction, use the GIS data by using compare the volume at different time. Then we also try to calculate the siltation rates by combining our GIS data with the dredging events data. Then we also correct our calculation with the flow depth data measured by NOAA in Port Arthur. So the first results I'm trying to present here is one of our GIS output. So you can see how the depths change at different time on the western side, which is where port facility is. The elevation can the siltation cause the depths increase very quickly. So we cut the cross section along the waterway and use the 3D analysis tool in the GIS that's on the deck side, which is present the cross section on this side, and this is the bank on the eastern side. They tip because the vessel needed to need to close to the facility here, so they typically need the more deep depth is more high here over this side. So you can see this is the cross section at different time. I only present the 10 years data here. I hope the video next slides can work. You can see how the cross-section change with time. At the station 150, we had a cut more than along this reach more than 10 cross-sections, try to see how that's going to change with time. And after we had all the data analysis use GIS, then we export those data to the Excel sheets, and we can use the Excel to calculate our reduction. This is the results show you the reduction rates and the siltation rates. So the positive value here, it's showing the reduction rates at different stations. The negative numbers here is the dredging occurrence, how much dredging is occurring at different location. Then we combine our calculation from the data analysis the GIS data and the dredging events with the flood data we found from the NOAA stations, then corresponding the dredging event with our total flow volume, and we find that identify these three big events actually have much impact for the sediment deposition. First is drought happened in 2014 to 2016, and Harvey in 2017, and Amanda in 2019. So we also compare our calculation with the actual rates for before 2017. The data was pretty close. Only when we have the data for the Amanda time, it's off because the time was not consistent. Then we also use our previous study, develop a B-stem model, try to figure out how much if the sediment deposition can caused by wake wash. So that using the soil data and bank geometry, in the model we find if we have the sediment, if erosion protection use large depress, it will protect the bank and the toe very well. So that's why we identify this is not a dominant cause for the sediment deposition in this part. So our current efforts is try to develop a HACRAS model using the barometric data just measured by Port Arthur. Then we also have the sediment grain size distribution in the river and flow data. We will look at from the NOAA website. So this is the current. We already import the survey data in HACRAS that was showing this part of the waterway, how the depths change along the waterway here and the side here, and we cut a cross section in the HACRAS. That's what the 3D river looks like. We hope we can get some sediment transport rate results by the end of next month. We also plan to develop a 3D hydrodynamic and transport model, try to include a tide effect. Then we're going to compare both models, try to demonstrate what is the best flow rate region which can control the sediment transport mechanics better in this part of the waterway. Conclusion for this study is the first is the wake wash is not a dominant sediment load process. If we have enough, the plant can have same the capacity to as the large water depress, it can control the erosion from the wake wash. And historic data, flow data and dredging data indicate the flow condition is the dominant cause for the sediment load in this part of the waterway. So we hope our model study can give a better, predict a better flow rate region to identify the how this sediment transport mechanic in this part of the waterway. Hopefully that can give some recommendation how to decrease the dredging activities in this part of the waterway. So we would like to thank you, Mr. Aitlong and Laura Kelly from Port also provide all the data and show us the port activities and field conditions. And we also like to thank you, Dr. Leaf and Center for Advanced Port Management provide the support for the graduate student Jennifer to conduct this study. If that's all for my presentation here. So any questions? I appreciate your questions.
So Dr. Chian, thank you very much. So basically, it looks like these big events, whether they're on the extreme of drought or the extreme on flooding, happen to be what causes the most sedimentation there by the port. Is that correct?
Yes, you're right.
Was that an expected result?
Yes, because when you have the flow rate, the flow has the capacity to carry the sediment in a certain way. So if you're too small or too big, they're gonna the balance between the water and the sediment will be destroyed. That's why you possibly have the deposition feed by the flow.
Do you at this point have any ideas of how we can mitigate that, or is this further study?
There should be further study because that's the model. When we have the model results, we kind of have the range. However, a lot of complicated the mechanics behind. We probably need a field study, more field study, and experiment, maybe lab study will be needed.
So are there any of the participants for this who would like to ask Dr. Chian any other questions? You can unmute and you're welcome to speak or type a question in the chat box. While we're waiting to see if somebody else has a question there, it would be interesting to know, this was specifically at the Port of Port Arthur there along the channel. Do you expect this to be similar at other ports or other lengths of the channel?
If we look at it, that should be very similar, Dr. Lee, because the geometry of the waterway, they're very similar, and the structures and the flow condition, they're also very similar. So.
Okay, so I don't see any hands raised or chats. Again, if somebody has a question, raise your hand or unmute.
We have an email here. You can direct to send me email if you have question.
Oh, that'd be great. So it's Dr. Chin Chian here at Lamar University. And thank you very much for your presentation, Dr. Chian.
My pleasure. Thank you, Dr. Lee.
All right. And so with that, if you would stop sharing, our next presenter is Dr. Fuller, who's going to present on an up-and-coming project that will kick off this spring on high-frequency radar. Dr. Fuller.
All right, good morning. Are you guys seeing my screen?
Yes, we are.
All right, well, thanks for inviting me, Lee. Again, my name's Chris Fuller. I work for RATE, so we're a not-for-profit. We teamed with University of Texas and Lee Hasselbach or Lamar University on a CMP proposal that it got awarded. We're expecting the contract to come through in April. We're pretty excited about this project. I just kind of wanted to give you an overview of what it is and some of the first steps that we're taking in this project to get it going. So I guess I should also mention that this project is actually funded by the Texas General Land Office. It was a coastal management plan project, and it's a project of special merit. So this is the funding is actually coming out of the Bureau of Energy. What is it? The BOEM. I never can remember that. The Bureau of Ocean Energy Management. So that's who's funding this project. So what is high frequency radar, and what is the network, and what does it do? So basically, this is a system. It was developed by Codar. They're out of California. They've been doing this for, I guess, 30, 40 years now. But anyway, you use a set of radar stations at basically 2 locations to map surface currents, to give you 2-dimensional maps and give you a vector field over a study area. What you're looking at in this photograph is what we had in Corpus Christi Bay. I can't believe it's 2000 when I'm looking at this. That's how long ago I was at the Blue Tree Institute doing this work. We finally got it funded again for the Texas coast. But anyway, you have 2 stations. Where my cursor is here, you're seeing a station at North Beach. And then we had another station over here near Corpus Christi State University, or I guess it's Texas A&M University Corpus Christi now. So basically, at each station, you'll get velocity currents along radials emanating from each station. At the intersection of these radials, you can actually get a total resolved current. So in real time, or near real time, we can get 2-dimensional surface current maps over an entire study area. So the idea is to bring this back to Galveston Bay and Sabine Lake. It has a lot of oil spill response applications. We're also looking at it for hydrodynamic modeling, dredge analysis, looking at storm events. You know, hydrodynamics, it affects it affects your storm surge, and also when it interacts with floodwaters coming down the Sabine Neches waterway. And we're also looking at it for non-point source pollutant transport modeling. This study that you're looking at here that we did in Corpus Christi Bay, we're actually able to combine this with other monitoring techniques to show that we had stratified flows within Corpus Christi Bay that led to hypoxia. So it has a lot of applications. So let me just catch my breath here a second. The data from this system, it's uploaded to the NOAA National Data Buoy Center, and the radial vector is available there. What you're looking at here is what's currently operated by the Geophysical Environmental Research Group, or GERG, at Texas A&M University. This is what they have in operation right now, but they're primarily looking at the offshore area. So they have stations right now all the way down at, this is Padre Island National Seashore, all the way up to, I think they're just north of Rollover. Now, actually, that's Freeport right there. So, but they do have another station at Rollover Pass. So they have coverage offshore, pretty much from Rollover Pass down to Corpus Christi, offshore Corpus Christi. So where we are right now in this, again, the project, we're expecting the contract to be executed April 1. So right now, what we're really looking at is site selection. We have to start putting together a list of potential sites for installing our the remote stations. There are a few criteria that are pretty important when selecting a site. One, the pairs have to be within the proper spacing. The radars have a limited range, so we have to be within the operational range of those. The 2 units have to be within the operational range of each other. Also, we had to consider line of sight of those stations. Another thing we're looking for is there power available? These stations, they operate continuously, so they do require a substantial amount of power to operate. Not so much substantial from the terms of having grid power, but if you're having to provide remote power for it, it does get pretty expensive. Like when I say remote power, like an off-grid system with a solar panel or wind generator. Also, we have to have a good communication link. We have to have Wi-Fi communication to bring the data from the remote sites to a central site where the data can be combined and shipped to the NOAA folks for dissemination on their website. We also have to look for interferences. These could be Radio interferences, we have to make sure that our systems aren't interfering with other users of that bandwidth, and also make sure that theirs don't interfere with ours. We're also have to look at the presence of interfering structures. If we have like power lines, they can interfere with our signals as well as towers and just large structures. Also, buried power lines and pipelines can also impact our signals. So just to kind of give you some examples of how we deploy these systems, we've had several different installations. Some cases, we've had mobile trailers where we could move to site and actually set these up on a temporary basis. And, of course, it has to be air conditioned in our neck of the woods. It gets pretty hot along the coast in the summertime, or for any time of the year for that matter. Also have to be protected from the salt spray and the conditions along the coast. Then we have, basically we'll run a coax from basically the electronics enclosure to our transmit and receive antenna, which needs to be set up in close proximity to the water. These are some examples. This is an example at North Padre Island. Here's an example. This is actually a mobile installation. I actually flew this down to Argentina, and we set this up at Bahia Blanca for a test down there with the National Science Foundation. And so sometimes we have to running our coax. That can be kind of problematic. This is a site that we had on Matagorda Island. We actually ran our coax across the dunes and actually raised it up on T-posts, pounded into the ground, and wired to the to keep it above the ground. It actually worked well because when we had a storm surge that kind of undermined it, our stuff was above that and protected. Just some examples. Again, here's some other examples of what this is a combined antenna, 42 megahertz. This is in Japan, and this is another one on Martha's Vineyard. So there's different types of applications, and it just depends on where you can set up the equipment. Again, I mentioned we have a couple study areas for this project. One is Galveston Bay. I just kind of put this in here for your information. If you're interested, we do have 3 potential sites that we're looking at to install, and we'll get into more of that when we get there. But just to keep in your back of the mind that is one study area that we have. We plan to install 3 stations, remote stations on Galveston Bay. And then for most of you folks, I think most of your interest lies in the Sabine Lake. So we do have 2 potential site locations for Sabine Lake. So the first area that we have, I called it Sabine Lake South in this map. That's located at South Levee Road near Martin Luther King. Again, this is a pretty low-lying area. This is pictures I took back in, seems like it was around Thanksgiving time, end of or first part of November. I guess you had a little storm there. You can see that this is a low-lying area. There's some flood debris along. This is the South Levee Road coming up. There's a power pole here. This is at Martin Luther King Drive. I think you're looking at about 500 feet or so from that to where I'm standing here when I took this picture. So that's just something to be considered, to consider when you do the installation, as well as elevation above the flood tide. But one of the things we really had to do is find a place that has access to this shoreline. Our antenna had to be placed close to that shoreline. Again, this picture right here is just showing that there is a power pole here. This is near the intersection of South Levee Road and Martin Luther King. So let's see. This is just kind of showing the properties in that area. To the west of the South Levee Road, this parcel here to the north, and this parcel here to the south section here, both of those are owned by the city of Port Arthur. Those will probably be our most likely candidates for getting access to install our equipment. A couple things to keep in mind. We've got a power pole here at the intersection of Martin Luther King Drive, and then to this location here, you're looking at about 1,000 feet. So that's about 1,000 feet to run power. So I believe access can be obtained here through the city of Port Arthur. These parcels here to the south, this area to the southeast along Martin Luther King Drive, those are privately owned parcels. If someone in this area has access to those property or know who owns those properties, those might be likely be potentially good or viable locations for us to install. But I'm just not sure about getting permission. But if anybody has any ideas, feel free to chime in. The next place we're looking at putting a station, looks like it's potentially viable, is the Sabine Lake at Pleasure Pier. So again, it's a park, it's publicly accessible. There is power there. We have a nice bulkhead, which gives us a lot of freeboard above the Sabine Lake level. I think it's a promising location and also has a good line of sight toward the south and to the east. Again, this area, it's again owned by the city of Port Arthur. We just need to make our contacts once we kind of get the go ahead and get this contract executed and start working in that direction. So that's pretty much the end of what I have to present. Just wanted to make you guys available what we've got going on. And if you have if you can provide any help in getting this access and spreading the news about this project and letting people know it's out there. You know, we need interest in this project. That's part of the plan is to garner some support for this project to keep it sustainable. We think it's a valuable product or service for the state of Texas, and that's where we're headed. So with that, I'll stop talking and try to address any questions you might have.
Yeah, so thank you. Yeah, go ahead. Well, I guess I'm echoing. If someone would turn the mic off. Maybe Chris, if you could turn your mic off for a second. All right. So thank you. I just want to say there was a question from the previous presentation by Steve Curran on has the port been involved with a hazard mitigation plan? And I assume he means the Port of Port Arthur. Unfortunately, Dr. Chian had to go off to teach a class, so I can't answer that. But that does a nice segue into this one of having more information in case there is, an oil spill. But Steve, I would invite you to email Larry at the port or Dr. Chian to get more information on that. And Chris, I would like you to repeat in one of your first slides on how this radar is used to inform the people on the call of how it might be used.
Yeah, certainly. You know, for one thing, that having this current maps, from an oil spill response perspective, having that data in real time gives them a really good handle on where to place their mitigation strategies, where they're going to be placing booms or they have a limited supply, limited manpower, and if you can direct it, it certainly helps things. Also, from looking at hydrodynamic studies, it's applicable to sediment transport models and what have you. Also, we're working with Texas Water Development Board on several projects. They do have they do have a big modeling program going right now. They use TextBlend right now. That they have TextBlend running for Sabine Lake. To my knowledge, that system has not been validated with actually with actual observed data. So that's one thing we would like to do with that, and that's also the model that the GLO uses to predict or to tell them what the currents are as text blend. So if we can validate that, that'll improve that tool for the General Land Office as well. Those are just some examples. Like in offshore applications, the Coast Guard uses this stuff quite a bit for search and rescue missions. There's been numerous cases, not numerous, but there's been several cases where they've actually used it to help find people who have been lost at sea and being transported. It's used quite a bit in pollutant transport modeling and stuff. They've used this to detect and predict the outfalls from the Tijuana River and the San Diego River. And again, like I mentioned in Corpus Christi Bay, we've actually used this to show that there was stratified flows in Corpus Christi Bay. Corpus Christi Bay, similar to Sabine Lake, very shallow, basically a pan, like a frying pan type profile. We did show density stratification in that bay, which was responsible for hypoxia. So there's quite a few applications of it, ranging from environmental engineering to water quality.
So, Dr. Fuller, the other thing is you had mentioned to me why it's really research in Sabine Lake, because people haven't been able to deploy it in this type of environment, because Sabine Lake is called a lake, not an estuary. Can you inform them why it's more challenging in the Sabine Lake?
The Sabine Lake does pose quite a few challenges. One thing about the HF radar is that you have an antenna in the offshore applications. We're looking out 100 miles. You're looking out over the horizon with this radar, so it's more than line of sight. The way it can do this is it relies on the electrical conductivity of the seawater to propagate that signal out over the horizon and then back again. In freshwater conditions, you start to lose that conductivity, so your range is very limited. So Sabine Lake, as you all know, is brackish. When it floods, it goes almost to a freshwater conditions, but we know it's a brackish one. I see redfish down there, and it's a big redfish fish. People like to fish for their trout and stuff there. I know it's a great place there. So it should work. I'm thinking it's got a lot of potential, but we need to demonstrate that it has not been done. Another thing that you have to look at is our signal depends on the wavelength. So, Sabine Lake is pretty small, so our wave field's going to be, you have to match up the wave field with the, how do I explain this? With the wavelength of the radar. So basically you need a wavelength that's 1/2 of the wavelength of the radar. So in our case, we're targeting a 42 megahertz. I can't remember off the top of my head what the wavelength of that is, but I think it's, I don't want to get into that because I can't remember the specifics. It's been a while since I looked at it, but those are some of the challenges. So we're, in this case, it's kind of a test situation. We just want to make sure it works, and if it does, great. So
with that, is there anybody else with questions? You can type it in your chat box or raise your hand or just open up your mic and ask questions. And while I'm waiting to see that, I wanted to thank Dr. Fuller and UT El Paso and UT Rio Grande Valley and RATES and all for involving Lamar University and us here in Southeast Texas. We seem to sometimes not get as much attention as the rest of the Texas coastline, and yet we have such important industry and culture and facilities here. And as you know, we have a bit of more challenges than other places. So thanks for involving us, and thanks for bringing us along on this. And I really, really hope that the data that we get from this can be meaningful to the waterways and the ports along Sabine Lake, in addition to the industry there for hazard situations. So I don't see any questions. So with that, I want to thank Dr. Fuller very much. And we'll go on to the next presentation. Can you stop sharing, please? Okay. So the next presentation is by me. So here we go. And let's see. If someone could tell me if they see my slideshow so that I know it's being seen. Candace?
Yes, ma'am, you're fine. We see it.
Thank you. Okay. All right, so now I want to talk about some projects that they've asked the Southeast Texas Flood Coordination Study to see if we could work on here for our region. And they both have to do with some sort of flood sensor or a gauge. And the issue is mainly that there are river gauges on the Sabine and on the Neches rivers. And they're very good USGS gauges, and there's a whole network on it, and Christine should be presenting on that at the end. And then also Drainage District 6 here in Jefferson County and some other authorities have some other gauges, but they tend to be expensive. So in this area, since we have so much flooding, and the flooding isn't just flooding in floodplains, you know, from the rivers going into the more traditional floodplains that are modeled, or from the storm surge, which is also a huge, so both of those are huge problems here. But what is really particularly unique here is what we call urban flooding. Urban flooding exists all over the United States, and urban flooding is when, you know, it rains in your city and the drainage systems and whatever don't handle it, and you have some flooding, you can't go down a road, or underpasses are blocked and things like that. And that's very, very common. What's not common is to do something like a Harvey or an Imelda, which is amazing, where in addition to the river flooding and potentially the storm surges that some other storms have brought here, we have this flooding that will flood neighborhoods and roadways and all in areas that are not caused by the river or the storm surge. So what has been asked is we need more information on it. And Carmen Apple, as I said, she's been called away to a COVID vaccination program here for the state of Texas. She works for the Texas Division of Emergency Management. Her and the other emergency managers have basically told us that what they need for, you know, rescue and response is sort of an approximate depth along roadways and other things. 1 foot depth means you can't go with a small sedan car. You might need, you know, more of an F-150 Ford truck to go those. If it's a 3 foot depth, they need a high water vehicle. If it's a 6 foot depth, they need a boat. And if it's a 9 foot depth, then they're talking about helicopters. But even for that, for rescuing, we're also talking about bringing in supplies and everything else here. If roadways are blocked, what are the other routes you can do, and how do we know which roadways are blocked and all for it? So, or what neighborhoods they can get through and which neighborhoods they can't get through, etc. So the questions they ask a lot of times is how fast is it flooding? How deep is it flooding? And is it receding? And how fast is it receding? And when we'll be able to go through. So what's of interest here, and they've asked, a lot of people have asked, is to have more data than the typical river or some specific drainage districts flow meters that they have there. So having this information on both historical and real-time flood depths is obviously beneficial for modeling and planning for mitigation, because then you know, well, it actually flooded there, and frankly also to prove to FEMA that, yeah, the water depth was this deep there. especially because one of the projects I'm going to talk about, the sensors are actually from FEMA. And then obviously, based on what Carmen and the other emergency managers have told us, it's crucial for response and recovery activities. And so this is the slide from Carmen that the Texas Division of Emergency Management was created as a state agency, and they're tasked with all phases of emergency management for the state of Texas. And as you can see there, the flood one is the upper left picture with it. So one of the efforts that we've tried to do here at Lamar University and the University of Texas has done, and now we're also working with the Institute for Disaster Resilient Texas at A&M, which was just established last year by the Texas state government, is the urban flooding in Beaumont, or the region here, the multi-county region from Harvey and from Imelda. When I say urban flooding, that's areas that you're not in a normal river floodplain, or you're not right on the coast for the coast surge. So we were trying to collect high watermark data, and I want to tell you that during after a big storm, the USGS with the National Water Service and the U.S. Army Corps of Engineers, they actually have a whole program. They send people out to try and find those high watermarks. If you remember in Dr. Fuller's picture where you saw that debris there, that's an indication of a high watermark where the water was pushing this debris up to that level. So they do that along the rivers and along the coastal areas, but not necessarily in these neighborhoods that have been such severe flooding here. So instead, we've been working by getting damage reports that are collected by the floodplain managers in the cities and counties. And if they're in a floodplain, we might be able to get an elevation certificate. These are on structures, commercial, residential, and institutional structures. And as I said, the certificates are really only available for structures that have been listed in a flood zone and, went for flood insurance. So we've been challenged with just mainly getting damage reports for some of these and seeing what we could do. If you see those green ovals there, those happen to be some neighborhoods where there was extensive data, and we have a group here that's working with that, and we're using LiDAR data and GIS maps to estimate the depth above the land elevation there so that we can do a potential inundation map for what happened in Imelda. And why this is important now is it gives you better information on how to make mitigation and design for future mitigation, and it also helps for them to validate the models that a lot of the hydrologists and the USGS and all are working on nationally in the National Water Center to try and also bring this type of flooding into us. So I just want to tell we're doing that, but with that, let's talk about collecting data for the future. So one of the ideas that was suggested by Al Ray, who happens to be the National Hydrography Lead for the USGS nationally, is that, a simple thing is to put what I would call a yardstick, but they call it a staff gauge. So you basically put it on a pole or something, and people can, in this day and age with our cell phones and all, you can take a picture of it that's dated and time-stamped, and you actually get some information. They have programs across the country where they have these signs on up. We're looking into that. We're really in the preliminary stages for that. There's issues of you don't want people to have to stop and take pictures at a busy intersection, on where there's also issues on what structures we might be able to put them on. It's looking very promising that our major utility company here might be willing to have it. But then the big thing is, where was this data go? So in this day with crowdsourcing and stuff like that, we're hoping that the Institute for Disaster Resilient Texas will eventually have a program that people can use an app and do it. We are very much in the preliminary part of this, and it would be interesting if industries and other entities here might want to join us in the efforts to see if this can be something that's viable. What's really cool about it is that it invites other people to participate in this versus just the people that drainage districts or the decision makers. It has everyone involved in the process. So with that, let's go on to the next program that I'd like to talk about. This one is very exciting. We are in the midst of seeing if we can launch this. There's a lot of interest in it. So the Department of Homeland Security over the last few years did one of the small business projects to try and have low cost flood sensors developed. And why is because if we want to deploy them into neighborhoods or under underpasses or at outfalls or by critical structure or roadway access to your facilities, so you have some idea of what's happening there, you know, you can't spend millions and millions of dollars to do the much more extensive type of ones they use in the major rivers. So it's their low-cost Internet of Things flood sensor program, because these sensors would tell you the level of the water, and they also would then send that so that the information is available real time for people to use. These two slides are from Jeff Booth, who was the director from Homeland Security Science and Technology, Sensors and Platforms Technology Center. So these low-cost sensors, they've been working on them for several years. They've done their beta tests and their alpha tests at other places like the Charlotte, Mecklenburg County in North Carolina area, had 75 of them, and there is 2 to 3 other areas across the country. They've had them developed, they've had them tested for, can they endure being flooded, how much, you know, impact can they endure, et cetera, et cetera. And they've come up with basically sensors that cost around $2,500. And with that, they have invited Southeast Texas through our Texas Division of Emergency Management if we would like to acquire 75 of their sensors to deploy here as more deployment. They're very interested in it, and they're very interested in us deploying them for different uses. As I said, critical infrastructure under underpasses in neighborhoods, some of them for testing and whatnot. If you can see the sensor there, they have the body of the sensor, and then there's a cable that goes down with a pressure sensor that you put in the water. And then it's solar powered, so it can be deployed where you don't have power. And then the signal goes through here. It happens to be through the Verizon network, which is pretty much available for Southeast Texas. And then it goes to some center where they have it. And one of the centers that they use where it could be put on a website is called OneRain. And OneRain happens to be the program that the Sabine River Authority and the Lower Neches Valley Authority use for all the river gauges on their rivers. They call it Southeast Texas Rain. And it is also the network that Drainage District 6 here in Jefferson County has just started working with also. So just so you can have some idea, because we're interested in more people partnering with the group over the next few weeks, we have meetings. I just presented to the Jefferson County Commissioners Court a workshop on that for it. I've presented at the Southeast Texas Flood Control District, and we have some ad hoc task groups from several counties and drainage districts, industry, other people involved in it to see if we can launch this. What's unique about us is that we're not launching it for just one entity, but we're launching it for many of our neighbors and people impact. So it is an asset management challenge, and very much so. And I'd like to thank the Center for Advances in Port Management. They're also helping us with Lamar University has offered to help with the initial asset management of figuring out who to how to get these and who to deploy them to. They do require some reporting, etc. They are low cost. They're low cost for installation and then low cost for maintenance for them. You can see that the unit itself, they have a special bracket that can go on wall mounts. It can go around poles, etc. To put it many places. And then you have the sensor, and the sensor obviously is in the water. Now the sensor could be in water, like in a bayou or in a culvert, etc. But it can also be on dry land in a neighborhood next to a roadway that has some frequent flooding and all. And then there's different ways that they have that installed for it. So I want to show you some uses that they've used it around the country. You can see there they have it on this creek, and to see the level of that creek, which is a constant one. They have it in more of just a wildlife wetland area that only has flooding occasionally. You can see one there attached to a bridge, other ones attached to other structures, the electrical structures that are there already. They have one where they also, for information, put one of these staff gauges with it. And then in some places, that happens to be North Carolina, their whole program has these signs that they put with it. Here, we've been talking about some of the possible uses are in the bayous or the creeks, some in the ditches, some for road access, as I said, outfalls, underpasses. One that's pretty important is low water crossings. That's where a roadway sometimes get flooded over, and if you drive during that, your car could be, washed downstream. That would be an interesting one. Neighborhoods, obviously, critical infrastructure. We would also like some applications with testing and calibration, and there has been an offer that they might, one of our drainage districts might put a few of them paired with the larger USGS gauges so that we can validate that they are giving us information here. Another interesting use is temporary uses when during construction and all, when drainage is diverted and things like that, or other uses that you could think of. Here again, I'm showing a few other ways where they're deployed. And they have done that. The main unit itself is resistant tested for submersion. I'm not sure how deep submersion, but we do have challenges here that are unique, more than some of the places they've been deployed around the country, because we actually have a lot deeper urban flooding than is experienced in other places, and massive depths, as you know from the pictures from Hurricane Harvey. And then the other picture I've shown there is for a low water crossing there, how it may go directly to a signal that then flashes and tells people, please don't go on this roadway, and we could do that in real time. So what do we do next? The person who is from the Texas Division of Emergency Management who has brought this forward to us is Michael Ouimet. And then there's also the gentleman from the Department of Homeland Security, a group. And what would happen first is there would need to be a cooperative research and development agreement between the Department of Homeland Security and Texas Division of Emergency Management, because these sensors are the property of the federal government and they would be deployed here. And then eventually, after a few years, their value would be less. And the intention is to keep them here permanently. Some of the sensors may not be deployed right away. They might be saved as spares for vandalism, when they find other applications for it, etc. So we're working together with the Flood Coordination District, which is that 8-county incorporated district that was just incorporated, I believe, last year. And what we're working on is a needs assessment and planning for it. And so this is my request to you, if you have interest in perhaps acquiring a few of these sensors for applications that you see, and join our cooperative, or whatever we're going to call it, that would be wonderful. The flood control district will then need a small project charter, so we have, who makes the decisions. The decisions of deployment would be by the people who are using them, of where they want them to be, and then, overall control, final decisions would be by the flood control district, and Lamar has offered to be the facilitator for it. With the budget, it doesn't cost that much to install them, unless they have to be put up on large platforms and all, but otherwise maybe $75 of equipment and all. And then with it, there is some operational expenses. One is the Verizon monthly fee is about $10 a month, but fortunately the federal government has sponsored that through mid-2022. And then the One Rain, and fortunately with that, since we have 2 of the One Rain networks in the area, we may be able to put them up to there with little or no charge. And then obviously some program management over the years for reporting back and making sure that this extends to other things. They also have other sensors you can purchase that go in the same network, such as rain gauges. This one sensor does flood level and does have a still camera on it. And then we'd like to deploy them. Hopefully we can start sometime this year and then monitor the project as we go. So with that, I am going to stop sharing and ask if there are questions of this. All right. So does anyone have any questions?
Yeah, Lieb, this is Joe Kruger.
Hi.
Hi there. Can you tell me how the sensors determine what the depth of the water is?
I believe by pressure.
Okay, piezometers. All right, thank you.
Lieb, do you already have the sensors, or they're providing you the sensors?
So the sensors will be provided here after CRADA is developed between Texas Division of Emergency Management and Department of Homeland Security, and then they can come here. We just have these couple of steps of planning it first, you know, so that we can say it. And I know Michael Wieman is talking back and forth with the Department of Homeland Security saying that, yes, Southeast Texas is our viable one for you to deploy these. It's a set of 75 sensors, and we'd like them here in Texas and not going elsewhere.
So they're providing them to you as like a beta test? Is that what this is?
They've already done the alpha and beta test. No, this is for more advanced deployment. Part of their development was to facilitate some of the initial deployment of it, and this would be the facilitation. So instead of us buying them separately and all, they actually have this set to provide for us.
And then I guess the deployment would involve an elevation survey, so you could determine that the stage height at that relative to some datum.
Yeah, so the different users, they already have that information. So the different entities we've talked to are the cities here, the drainage districts here, the counties here, industry here, and stuff. And a lot of them already have that information on their maps, and they are already looking at, several of them are looking at, you know, I could really use it over here, or I could use it in this neighborhood there, or I could use it for the outfalls. I know the city of Beaumont's very interested in having this at their outfalls so that they can understand how the drainage is going. So a big part of it for them is monitoring their system, not during only the large events, but other times. So, you know, you can imagine that if they see that there's a change, it may be there's blocks in some of their system, et cetera, as they go. But for emergency management, we're looking for more the neighborhoods and the roadways so that people know how fast it's flooding, and more for the extreme events. Are there any other questions? I don't see any hands raised or questions in that. So with this, I'd like to see if Christine is available. Christine, are you here?
I am.
Hi, so if you would share your screen, I'd like to introduce her. She works for the Center for Water and Environment at the University of Texas, and they have been a great supporter of all our work here in Southeast Texas. Thank you, Christine.
You bet. Can y'all see my screen? Did I hit the right button? Okay, good. So today what I'm going to do is I'm going to go ahead and cover some exercise outcomes from our Homeland Security Exercise Evaluation Program. But first of all, let me just give you a little background on me. My name is Christine Teese, and I do work for the University of Texas and the Center for Water and the Environment. But my first 25 years of my career was with public safety. So I worked for the city of Austin and with the police department and mainly the fire department. And so when I retired and kind of came over to UT, my role and another coworker of mine, which is Chief Harry Evans, who was the chief of staff at the Austin Fire Department for a long time. Our roles are really to try to help bridge the science with public safety. So the scientists are doing some very complicated modeling, but sometimes they're not quite sure how to utilize that and allow the outside world to utilize it to actually make a change. And public safety is, they just assume that it's just, you just snap your fingers and magically information appears. So we try to help kind of bridge those two together. And one of the ways to kind of do that is through this exercise, which is we refer to it as an HSEEP exercise. And these are very structured exercises where the participants that come in are going to test something. And they receive limited introduction to the question or the product. And then we look at the product and we run through scenarios. So we kind of, pivot. You're working on a flood. What kind of data do you need? And then, all of a sudden now we have this. And so how does the product or the information or the tools, could be a physical tool that you have, work within that particular scenario? And from those, you get kind of this guide, this improvement plan, the guiding findings that allow that agency or university or area to say, oh, these are the things that we probably need to implement to improve, let's just say, response in our area. So we did 2 of these recently. We did one in May. The other thing, just a little tiny side note, is HSEEP exercises are, 100% of the time they were in person. So they're very much, you're collaborating with the person next to you. You may be broken out into groups. Obviously, COVID changed that, and through Lee's guidance, she was like, "We can do this virtually." Harry and I were like, "Oh, I don't know if we actually can," but we did, and so we actually did this as a virtual exercise. And so in May, this was actually more focused on, is the information that's available out there, can it be used by the public safety groups, but really more trying to train non-public safety individuals on the questions that public safety asks. So actually there were no public safety people in the May exercise. And then in November, we did one on a website called southeasttexasrain.org. And we ran that, we brought in public safety individuals with some scientists and hydrologists and academics to see their reaction and how they would use the website. So real quick, that's just kind of the background. So let's go, we're going to go through these exercises and then talk about what the outcomes were and kind of how they overlap. The first one, which was this, was the exercise that focused on helping non-public safety personnel better understand the needs that emergency managers and first responders have during a flooding event. What are the questions they ask? What do they do? How are they thinking? And, the people that were involved were floodplain managers, drainage district managers. You can read this, USGS, Corps of Engineers, and university faculty. But the interesting thing, and Leave was right, we were just like, no one's going to come to this virtual exercise. We had almost 50 people, which was kind of shocking. And it worked much better than we thought it was going to. We actually got a lot of information. So what came out of that is what we found some things that were working and some things that could be improved. Bottom line, this area has got a lot of collaboration. They know who to call. They are used to talking to each other. They may not understand how that particular agency deals with the information, but they know who to call. So that was really, really, it was helpful. And it was, I was really thankful actually that was going on. Unfortunately, the reason they collaborate really well is because Southeast Texas has a strong historical experience. Y'all are just getting, hit by these storms way more than one should. Also, they talked about using drones, and then they also, the group felt like they had pretty good access to the flood and water data. But things that could have been improved, and this is again not from the public safety perspective, but there really isn't one portal for all of this regional flood data. you need to kind of have been in your job for a while, and you know to go to this website or go to, you know, this data portal, and you just know how to bring the information in. It would be very nice if there was a one-stop shop when it came to data. Also, there just needs to be some improved mapping with predictions, because the reality is public safety communicates through there. It's a very spatial industry. It's a they like maps. They like information on maps. It means a lot to them. They can move forward when you put information on a map. Also, we need to improve on the flood, inundation, and water depth. Also, education. We need to try to expand on educating the public safety and emergency managers on local water behavior. The district, the local hydrologists and the district managers, they know so much about their area, and they're like, oh, that floods when this happens, this floods when this happens, which is usually found in the data, but they know all this additional information that sometimes we need to communicate. And then the last thing was really just trying to communicate out to the public some things that are happening and some information that's available. So with the Southeast Texas Rain exercise, which was done in November, this one was really to focus on this particular website. And it was sponsored by the Sabine River Authority. And because this is their website that they manage. And it was really just looking at it from public safety's perspective, not from the River Authority's perspective, not from another hydrologist or a drainage district perspective, really from public safety. And so, you know, we wanted to see, are there any small changes or even big changes that we could make to the website that would help communicate information to these non-science groups, the public safety groups. And again, we had floodplain managers, drainage district managers, emergency management and public safety, USGS, Corps of Engineers, and the Weather Service. This was another really big one, and some university faculty. And on this one, we had about 38 people that participated. So let's go back. Oh, I put these I put these backwards. What was oh no, this is right. So this is what was working with the Southeast Texas Rain, which was, again, collaboration. The people knew who to call. Same thing, sadly, the strong historical experience. The website's accessible. People kind of actually knew where to go, and they kind of knew how to use it. And then the website also had embedded some other web links, like out to the Weather Service. So those were some things that were really good. Some things that could be improved was the map. We kind of talked about adding some additional layers like predictive data and some infrastructure, because honestly, public safety thinks very much in the line of infrastructure. What roads are closed, what buildings are impacted, how do we get the people in and out? How do we need to evacuate? Those are kind of the questions that they're running through. There were also missing some additional gauges, and this is kind of, I ran into this in public safety all the time. This one individual knows where all this information is, and then we kind of get into this group and they're like, why are my gauges not there? Oh, well, we either forgot to talk to you or we just didn't know who to ask. And so though they offered that up. So those were some kind of easy enhancements. And then also to expand this map with symbology, trying to communicate some of this local knowledge across the board. Also, this little picture, this is a picture that's available on a different rain.org site. I think it was in Sacramento County. Public safety looked at this and was like, this is a game changer. So really to go out and do some basically pictures to try to identify visually, where's the normal level, where's the inundation, and what does this mean? Again, to incorporate some local knowledge into the website, and then also add some web training for the flood community. They just hadn't done that yet. They weren't really sure, if anyone was interested. They weren't really sure who their audience was. They kind of knew public safety used it, but they weren't quite sure how. So that was one of the other things that we talked about that could be improved. So these are some similarities between the two exercises on what is working. And when you look at it, bingo, collaboration. Again, that kind of constant theme of collaboration came up in both exercises. And again, unfortunately, you've had a lot of hurricanes and storms. And then the other thing is that the website was similar. We spoke about Southeast Texas Rain in the first exercise. And so it was good to see that agencies are utilizing it. But when we talk about things that could be improved, there were some overlap as well. And again, improving the mapping that was a strong one that came across in both of those. And trying to highlight the flood, inundation, and water depth. How can we, kind of communicate some of that stage height across the board so that people can quickly look at it. Unfortunately for the science community, y'all are very, very, very good at the hydrographs, and they mean so much to you, but to public safety, they're just like, great, that's a chart. What does that mean? What does this mean? I'm looking at this chart and it's saying 22 feet on this particular creek. What's 22 feet? How far out? How many homes does it hit? So the map is a really good a common language that they can both use. And then again, to expand on the communication and training. So what comes out of these exercises is ultimately, this is it. So why are you doing these exercises? You're doing it to get an improvement plan. Give me a path forward. That's really the only reason to do it. And so these are the 8 things that kind of came out of the first exercise. And we have, what we do is we kind of say, this is the issue. This is the organization that's going to carry that forward. And then they're able to talk about timeline and kind of the elements. And as you can see over here, a lot of it is funding. Funding is necessary for Southeast Texas to get a lot of these things implemented. They just can't be done on their own. And so on these, the 8 were, to the centralized portal for local information. If we can get that set up and all the information is there, we really believe that both the academics, the hydrologist, and the public safety will be able to look at the same information and share it. The static maps of historical data collection, it is very useful to both the academic world and the public safety world. So academics can use it to double check their models. Same with hydrologists, but public safety thinks that way. I can tell you numerous times that Austin has been hit by a few large floods. And when we would be on scene, that's where hey, did it get that high last time? Did it get this high this time? And so they utilize some of that historical information to kind of determine how bad this scene is and possibly how bad it could get. Also communication, also, let's see, better mapping with predictions. That was a big one, and that's where the Weather Service is really working hard at trying to help with the predictions, and so is the National Water Center. The flood inundation, to educate the public safety, we want water flows and velocities and do some drone technology. And then through this Sabine exercise, now this is still draft, Sabine River Authority has not signed off on this, but basically those were enhancements to the web map, add the stage height bridges and the pictures, that little picture that was a game changer for public safety. And to, we need to incorporate some local knowledge. What does that mean? We're not quite sure, but we need to figure out a way to do that because there is a lot of it out there. And then also some web training for the community. So when we look at both of those, again, this particular list doesn't negate the original lists, but it does show that there is a lot of room for collaboration and support in the Southeast Texas area. And so both of them, this portal, that's going to work for both the website and for the hydrologists, the academics, and public safety across the board. The communication, this is where Sabine and Lamar can work together to make sure that their communication plan and their outreach is just cohesive, that that they feed, that they help one another. And so that was I was like, I knew that one was going to come out. Also to enhance the web map, that's where I think Lamar can help with kind of testing it out. So if Sabine comes back and says, hey, we did this, Lamar has the ability to kind of test it and say, yeah, no, that works. And then also those pictures with the road and bridge flood heights. There's a lot of bridges in Southeast Texas, and to go take pictures of all of those and add some of that graphics, I think that's where Lamar can really kind of help. So that's basically my presentation. I don't know if there's any questions that I can answer, or if there's anything else I can do to kind of explain a little bit of what we did.
So Christine, Dr. Fuller had a question, which I don't think you and I can answer, but I'll throw it out there. How are drones used to measure flows?
They're not, and I apologize if it came across that way. It's really about using the drones to go fly over flooded areas to double check the inundation.
And then damage, I believe, also.
And damage too. Yes, exactly. And damage. So I don't know about velocity. I don't think that would be the use. And I apologize. I'll double check on the presentation to make sure I didn't try to convey that, which I could.
No, thanks. I appreciate it. I was just, if there was new technology, I was just interested in it.
Oh yeah, no, don't ask me about new technology. I don't know, but no, it would really, you know, public safety tends to want to know where's our problem, how bad is it, and when is it going to go away? So that's where the drone technology can kind of help.
All right. With that, if anybody else has any questions, you raise your hand and or unmute yourself or write in the chat box. And Christina, I see you have done that. So if you bear with me 1 second here, I'm sharing. Oh, I got rid of my presentation. I was just 1 second as we wait for questions here. I unfortunately went out of my. All right. So if I share my screen. There. So with that, I just wanted to emphasize that all this work that we're doing here has been this amazing data and communication collaborative that people have joined with. And again, our 6 sponsors are listed there. And we also want to thank the Center for Port Management for inviting us to this webinar. I also, I'll share my screen in a minute in case there's more questions, but I would like to invite the participants. If there's some way that you want to have more information from Dr. Chian on her dredge studies and how it may facilitate information for your entity, or if you would like to help us with the high frequency radar deployment, if you know some way to help us be able to deploy that so it's effective for Sabine Lake. If you would like to be involved with the various low cost flood sensor program and maybe become part of that collaborative, or if you have other ideas with respect to the different things we are trying to focus on here based on our Homeland Security exercises, please let us know. And so let me do this, I'll share my screen. All right, and I am going to see if there's any other questions. Thank you, Shanna, for saying this is great. Again, we really invite you to join us and become part of this. And we are very grateful that this is going on. And frankly, for me, it looks like I'm going to be involved with this for the next like 5 years or so. And it's a pretty exciting thing to be able to have a impactful influence here on Southeast Texas. And the more we work together, as Christine says, communicating and collaborating, the better it'll be. So are there any other questions? No? I hope this was informative. I hope you enjoyed it. And I hope you guys all feel sorry for Dr. Fuller, who's up there where it's below 0 degrees. And we are waiting for in the teens here. And he thinks that's warm, but we are going to have a pretty rough weekend. Stay warm, everybody. Thank you for coming.
Thank you.